Hello friends, I welcome you all to this class. This is mathematics class, and today we are here to consider this topic, differentiation of sum or difference of functions. So we are still on this topic, differentiation. Though we consider differentiation from the first principle and differentiation using the power formula in our previous classes. But today we want to we want to know how to evaluate the derivative of sum or difference of functions. So remember, the power formula says in our previous class, the power formula we looked at, the power formula says that if you have a function f of x is equals to x raised to power k, then the derivative of the function, which is f prime of x, derivative of function with respect to x, will be given by, what is the power of x here? The power of x is what? K. So you are going to bring down that power of x, which is k, and use it to multiply your function x raised to power k. You remove 1 from the power, the index. This gives you the derivative. Then we are going to use this power formula to evaluate the derivative of sum or difference of function. So if you have sum or difference of functions, if you want to evaluate the derivative, you are going to evaluate the derivative of each of the terms of the function. That's, you evaluate the derivative of each of the terms of the function. That will give you the derivative of this function. So we have that we have the first example. That's question A. This is what is given to us. That's the first function. Of course, they are putting condition that x should not be 0, because if x becomes 0, you have 0 at the denominator, which will give infinity, making the function undefined. So the condition there is that, so they put the condition so that the function will be defined. That's the reason for the condition that x should not be 0. Now we want to find the derivative of this function using this power formula. But for you to use this power formula, we must know the power of x. But from what we have here, we have x at the denominator, so we need to simplify this using the knowledge of what? Indices. Using the knowledge of indices, we know that this is, we can, if you want to remove this fraction, you are going to introduce what? You are going to introduce negative sign on the index of what? F. So if I want to remove this fraction, remember I have 2 at the numerator, so I'll write 2, then I'll write x. Instead of this fraction, I'll remove this fraction, then I'll introduce negative sign on the index of x. I'll have minus 3, x raised to power minus 3. Then I have minus, so I'll do the same thing here. The numerator is what? 4. Then I write x. Then for me to remove this fraction, I will introduce negative sign on the index of x. Remember, the index of x at the denominator is what? 1. If I introduce negative sign on the index of x, I have minus 1. Then I have plus 6. So I've written it. I know the powers of x here in each of them. I know the powers of x in each of them, minus 3, minus 1. So I can use this power formula. So that the derivative f prime of x, derivative of this function with respect to x. So using this power formula, what's the index of x here? Minus 3. I'll bring it down. I'll use it to multiply the whole of the function. 2x raised to power minus 3. What do? You minus 1 from the power, minus 1. Then for this one, we have, what's the index of x here? Index of x here is minus 1. Multiply your function, minus 4 raised to power x, minus 4x raised to power minus 1. What do? You minus 1 from the index, minus 1. Then if you differentiate 6 is a constant. Derivative of constant is what? 0. So if you differentiate 6, you get 0. So this, if you do minus 3 multiply 2, minus 3 multiply 2, you are going to get what? Minus 6. So this will give us minus 6x raised to power. Then minus 3 minus 1 will give you what? Minus 4. Then we are done with this one. Then minus 1 multiply minus 4 will give you positive 4x raised to power. Minus 1 will give you minus 2. Then this gives us the derivative of this function. So we can go to the B part. So this is what we have, and we want to use the power formula to do that, to evaluate the derivative of this function. So for us to use the power formula, we must know the powers of what? X. So for the first one, I know the power of x. For the first one, the power of x is 2. Then for the second one, I need to simplify it to know the power of x. So I have plus 1 over, so you have 4th root of x. 1 over 4th root of x. 4th root is index 1 over 4. Square root is index 1 over 2. Third root is index 1 over 3. Fourth root is index 1 over 4. So fourth root, so this is x raised to power 1 over 4. So as then plus next one we have x raised to power minus 3. This one I don't need to simplify this one because I have known that the index of x is minus 3. Is this one I need to work on more. So I have x raised to power 2 plus. Then if I want to remove this division sign, I will have to introduce what? I have to introduce negative sign on the index of x. So I have what? X raised to power minus 1 over 4. So I have introduced the negative sign, then plus x raised to power minus 3. Now in our function, we know the powers of x to be 2 minus 1 over 4 and minus 3. So we can use the power rule to find the derivative. So I've put the formula we are using, the power formula we are using in brackets. I'll put it aside. Then because of space, we are going to continue our solving up here. So continue our solving up here. We need to do the derivative of the function with respect to x, right? F prime of x. Let's evaluate it. What's the power of x here? 2. So you are going to bring that 2 down and write your function x raised to power what? 2. What do? You minus 1 from the power. Then we are done with this one. Then the next one will have what? X raised to power minus 4. What's the index? The next one will have x raised to power minus 1 over 4. What's the index? The index is minus 1 over 4. You write it. Then you write your function x raised to power minus 1 over 4. After doing that, you remove 1 from the index, minus 1. Then the next one we have is x raised to power minus 3. You bring down the index. The index is what? Minus 3. Then you write your function x raised to power minus 3 and remove 1 from the index. Then you simplify further. The first one have 2x. 2 minus 1 will give you 1. That's x raised to power 1. But x raised to power 1 is same thing as x. So I can leave it as 2x. Then this one gave us, this one will be minus 1 over 4 x raised to power. Then you can simplify the fraction, that's the index of x. We have minus 1 over 4 minus 1, right, as the index of x. If you simplify, minus 1 over 4 minus 1 will give you minus 5 over 4. So then this one, the last one, we have the last one will have minus 3x raised to power. Minus 3 minus 1 will give you what? Minus 4. So we are done with that. Let me write the question C. So this is the question given to us. This is the f of this is the C part, question C. So we need to use this index formula. We need to know the index of what? X. We need to use this power formula. So to simplify this, we know that square root. What is square root? Square root is index what? 1 over 2, as I've told you earlier. So this square root of x is same as x raised to power 1 over 2. X raised to power half. Then this one will have plus. Remember, anytime you have fraction, you must use the law of indices to remove the fraction. But before doing that, we have square root of x, because we have 1 over square root of x. So we have square root of x as denominator. So, and I told you that square root is index what? 1 over 2. So I'll write square root of x as x raised to power 1 over 2. Then I'll have minus 7. Simplify further, I'll have x raised to power 1 over 2. Then you must remove this fraction. So to remove this fraction, I will introduce negative sign on the index of x. So I have plus x raised to power minus 1 over 2, then minus 7. Then clearly I know the index of x in each of the terms. I have the first term having the index of x is half. The other one, the index of x is minus half. So I can go ahead and use the power formula. So I can find the derivative of the function with respect to x. Then we go differentiating term by term. For the first term, the index of x is what? Half. Bringing down the index, you bring down the index and write your original function x raised to power what? Half. What do? You remove 1 from the index, right? Then you go to the next term. The next term is x raised to power minus half. So what is the index? The index is minus half. you bring down the index and write what you have, x raised to power minus half, and you remove what? 1 from the index, right? Then if you differentiate minus 7 is a number, that's a constant. The derivative is 0. So that's what we have there. Then if you simplify this, we have half. We have 1 over 2 x raised to power. Then if you simplify the index of x, 1 over 2 minus 1, that's half minus 1, will give you negative half. Then the other one we have minus 1 over 2, then x raised to power, we have minus 1 over 2 minus 1. So minus 1 over 2 minus 1 will give you what? If you simplify it, you are going to get what? Minus 3 over 2. Then this gives us the derivative of this very function. I hope you learned a lot from this class, and we are going to solve more examples on this topic. See you in our upcoming class. Bye.